Hi there, folks. Today we're looking at operations with positive and negative numbers. And the first thing we want to look at when we kind of talk about this is a number line. And then we also have to talk about the symbols that are on this number line. We see the positive numbers 0, 1, 2, 3, 4, 5. So the positive numbers 1, 2, 3, 4, 5. And then we see those, we call them negative numbers, negative 1, negative 2, negative 3, negative 4, negative 5. And I want to talk about that symbol, that negative symbol for a second. You know, when we look at this guy, a negative symbol, all right, we tend to think of it in two ways. We think of it as a negative symbol, like we see here with the numbers, or we think of it as like a minus sign or a subtraction sign, okay? But really, if we take a step further back, one of the ways that we can think of this kind of at its core, at the heart of this thing, is we can think of this as an opposite sign, okay? And see, the reason we call, negative 2 a negative 2 is because it's the opposite of a positive 2. And so thinking about it as an opposite sign really kind of goes back to what that thing really is in its heart of hearts, okay? And when we talk about numbers, numbers are negative. That's what happens when you look at the opposite of a negative. But when you think about it as an opposite sign, it makes certain things a lot easier for you, okay? And then from there, negative numbers kind of give us the foundation for subtraction and addition. So this symbol that we learned this symbol backwards, really. We learned that symbol first as a subtraction or a minus sign. Then we learned it as a negative sign. And now I'm telling you it's an opposite sign. But really, we should have taught you that in reverse. Really, it's an opposite sign, which is why we call them negative numbers. Really, it's an opposite sign, which gives us negative numbers, which gives us the idea of subtraction, okay? So keep that in mind. Think about it in terms of the opposite. Yeah, when it's numbers, we'll talk about it as negative, but keep that in the back of your mind. Think about it as the opposite, okay? So now looking at the number line, we know half of this number line really well. This half over here is the end that's counting up, obviously. 1, 2, 3, 4, and we know which of those things is bigger and which one is smaller, all right? But if we start tacking on the opposite, see, the opposite of a 1 is on the opposite side of the number line. The opposite of 2 is a negative 2, so that's on the other side of 0. So it's kind of reflected, all right, and it's in the same spot. So if I do 5, well, the opposite of that is a negative 5, and it's the same distance away in each direction, okay? So as we count up, 1, 2, 3, 4, 5, the values get bigger. But as we count towards the negatives, the values get smaller, okay? So over on this end, the values are getting smaller, which means if I'm comparing negative 2 and negative 3, well, negative 3 is smaller because it's further to the left. And that's how the number line works. As we go further to the right, it gets bigger. As we go further to the left, it gets smaller, all right? And the idea of thinking about it in terms of the opposite, just think, the bigger the number we see is, the opposite is smaller in just the other direction. Okay, it's more negative than the other numbers, so therefore it is smaller. Okay, so keep that in mind, and we want to kind of picture this number line in the back of our minds. Okay, for example, if I look at something like these guys, I want to know which value is bigger versus smaller, or maybe they're equal. And so I'm going to use these symbols. Remember, when you're using these symbols, that's a less than symbol, a greater than symbol, and an equal to symbol. Remember, with these guys, okay, these inequality symbols, which we'll look at more later in the year, the alligator, we think of them like an alligator. Remember, the alligator eats the bigger number, okay? So when we place these things, just make sure that the open end of this thing is going towards the larger value, okay? So something like this, 4 and negative 5, again, we look up at our number line, we say, okay, I see 4 is way up on the right, and negative 5 is way down towards the left. So remember, the farther right you go, the bigger the number is. The farther left you go, the smaller the number is. So in this one, the negative 5 is smaller, the positive 4 is bigger. So the alligator eats the positive 4, okay? And we can easily see that on the number line. But we don't want to have to draw a number line every time, so start to visualize that number line, okay? If I look at something like this, 3 and 5, that's an easy one. We probably don't need the number line. We know that 5 is more than 3, so I use this symbol. Okay, and keep in mind, you can read each of these two different ways. I could read this one as 3 is less than 5, or I could read it backward and say 5 is greater than 3. Okay, the next one, 3 and negative 3. Again, look at that number line. Positive 3 is more to the right. Negative 3 is more to the left. So the positive 3 is bigger. So I do a greater than symbol. 3 is greater than negative 3. All right. And yeah, of course, the positive is always bigger than the negative, okay? Because the negatives, the farther negative we go, the smaller we get. If I look at this one, -3, -5, this is where students get a little tripped up when we're comparing two negative numbers. But again, look at the number line. The farther left you go, the smaller it is. So on the number line, -5 is the smaller of the two values. -3 is farther to the right, so it's the bigger of the two values. So I'm going to say that -3 is greater than -5. Okay? And again, negatives equate to smaller values. So the more negative it is, the smaller it is. Okay? If I look at something like this guy, this one, -15 is not on this number line, so we can see where -4 is. Visualize, where would -15 be? And hopefully you're looking at this going, well, -15 would be way out here somewhere, right? So now think about it. Which one is smaller? Which one is bigger? Well, the farther left you go, the smaller it is. The farther right you go, the bigger it is. So in this one, -4 is greater than a -15. And again, the more negative it is, the smaller it is. 15 is more negative than the -4, okay? And then this guy, 5.2 versus 5.21. Again, think about it maybe even when you see decimals, think about it in terms of money. Like if you looked at this guy, it would be 5.20, $5.20 versus $5.21. Well, which one is more? And so as you're looking at this, again, think about where that would be on the number line. It would be 5.2 followed by 5.21. So the 5.21 is bigger. So I'm going to use this symbol, okay? So 5.2 is less than the 5.21. And then applying the same things to negative, again, because we're talking about the opposites, all right, the relationship is opposite. And so as you think about this, let me plug these in. So like if we were at the positive end, you'd probably go, oh, well, 3.43 is here, and then 3.45 is here. But now think about flipping those to the other side. The negative 3.43 would be here, and the negative, as it gets more negative, negative 3.45 would be here. So now think about which one is farther to the left, okay? The negative 3.45 is farther to the left, so that one's smaller. The negative 3.43 is farther to the right, so that one is bigger, okay? And again, when you think about it from the perspective of opposites, look at maybe this example right here. See that 3 is less than 5? But when we're talking about the opposites, -3 and -5, the opposite of true, -3, is greater than a -5. Okay? And so again, it goes back to that idea of these are opposite symbols, so it gives us the opposite result. Okay? We refer to them as negatives when we're on a number line. Okay? So let's talk about adding and subtracting. Adding and subtracting on a number line. If we're going with the same concept of the negatives, the more negative we are, the further to the left we go. The more positive we are, the farther to the right we go. So when we're talking about adding and subtracting, or really addition mainly, we'll talk about subtraction in a moment using that concept of opposite. But a negative means, hey, you move that many to the left. And the positive means you move that many to the right. For example, if I look at something like this guy, I start with a positive 4. So I go 4 to the right. So I go 1, 2, 3, 4, and puts me right here, right? Puts me at positive 4. But then I have a -5, which means I have to go 5 to the left. Ready? 1, 2, 3, 4, 5. It drops me off right here. So when I add those two together, the result is a -1. Okay? I went 4 to the right and then went back 5. I went 5 to the left. Where did it drop me off? -1. Okay? That's the idea of using a number line. And again, we don't want to have to draw a number line every time, but if you can visualize that number line in your head, well, then this isn't too bad. If I look at this one, I have a -3 first. So -3 is right here. So I went 3 to the left. That's what brought me to -3. And now plus 5, positive 5, that's 5 to the right. Ready? 1, 2, 3, 4, 5, drops me off right here, positive 2. And again, try to start visualizing that number line. If I look at this one, positive 3, so 3 to the right. 1, 2, 3 right here. And now -3 means go to the left 3. Ready? 1, 2, 3. Oh, it drops me off back here at 0. That's how adding positive and negative numbers works, okay? If I look at this one, I've got -3, so I go to the left 3. 1, 2, 3, here it is. And now I've got another -5, so I go 5 more to the left. See, that says, hey, go to the left 5. Ready? 1, 2, 3, 4, 5. And here's the thing, I ran out of space on my number line. We're going to have to imagine what this thing is. We're going to have to use our imaginations. And you can extend this and write these out if you want. -6, -7. Oh, there it is, -8. Okay? And hopefully, you're kind of seeing a relationship here between the positive and the negative numbers in terms of when the signs are different, like 4 and -5, okay? We got a smaller value than 4 and 5. When we had the 3 and the -3 and the 5, again, we got a smaller value. But when we had the -3 and the -5, when they were both negative, we got a bigger negative value. So keep that kind of stuff in mind. If I look at something like this guy, again, 4 minus 5, we know that that minus sign, just like a negative sign, because it's all the same symbol, it means, hey, move to the left that many. So right here, I've got a +4, which would put me here. And now I go to the left 5 because it's -5. 1, 2, 3, 4, 5. There it is, -1. If I look at the next one, this one's a little bit tricky, but again, we want to think of it in terms of opposites. So I start with -4. -4 is right here. And now I want to do the opposite. See right here, minus -5. That's like the opposite. So if we think of that as an opposite symbol instead of a minus sign, I mean, because that's really what it is. It's saying do the opposite of a -5, an opposite of a -5. See, normally -5 would move me to the left, but it's saying do the opposite of that, so I'm going to move 5 to the right. 1, 2, 3, 4, 5. Oh, look at that, +1. Okay? If I look at something like this guy, once again, I'm starting at a +6. So I start up at +6, which, again, it's off my number line, but that's okay. It's right here. And now I want to do the opposite of a -2, right? When I see that symbol, if I think about it as opposite of a -2, well, normally -2 would move me to the left. But I want to do the opposite, so I'm going to move 2 to the right. 1, 2. And yeah, I ran out of space here, but can everyone see where we are without me writing the two values? Count up there. Yeah, that's a +8. If I look at this one, again, we're starting at a -3. So we start at -3. That's right here. And now I want to do the opposite of a -8. Normally, -8 would move me to the left, right? But this has two negatives, so it's got a minus sign and then a negative. So it's the opposite of doing the -8. So normally, -8 moves me to the left. I'm going to do the opposite and move to the right. 1, 2, 3, 4, 5, 6, 7, 8. Look at that. +5. Okay? And now, here's the question. What do you notice? What do you notice here? In the examples above, when is subtraction the same as adding? Like when you look at something like this guy right here, -4 minus a -5, that's the same thing as -4 plus 5. And right here, 6 minus a -2, that's the same as 6 plus 2, right? To get that 8. Here, -3 minus a -8, that's like adding 8, and that gives us a +5, okay? And here's the thing, we did some of these examples in different ways, like this one right here. If you look at these first two, that's an interesting case because it's really the same question. 4 plus a -5 was the same as 4 minus the 5, okay? And so what we can do is if we think about that from the perspective of the opposite, all right, subtraction is the same as addition if we do the opposite, okay? So when we do the opposite. So if I have subtraction, if I want to do addition instead, I can. I just have to do the opposite of what I had. Okay? So like in this one. Here, let me bring this guy down as an example. Instead of doing subtraction, 4, instead of doing -5, I could do plus, and now I just have to do the opposite. Instead of 5, I do -5. Okay? It's the same as adding the opposite. And then what do we notice about subtracting negatives? Subtracting negatives were the same as adding the opposite, adding a positive. This is the same question asked twice from two different perspectives. More generically, yeah, we're doing the opposite, okay? Subtraction is the same when I do the opposite of that thing, okay? And what happens when we're subtracting negatives? Well, we add a positive instead. We do the opposite of all those things, okay? The other way we can look at this, instead of looking at a number line, is using what we call neutral fields. And you don't have to know that term, neutral fields. The idea here is that adding and the minus sign, they're opposites, okay? Remember, that minus sign is an opposite sign. So what happens is they cancel out. And we kind of saw that in one of these examples right here. Here's the example where they canceled out right here. A positive 3 and a negative 3, well, they added up to 0. And really, if we ever do the opposites, if I do a positive 4 and a negative 4, they're going to add up to 0. I go left 4 and right 4, and I'm back at 0. If I do a positive 5 and a negative 5, I go right 5 and left 5, and I'm back at 0. So anytime I have two things that are the same but opposites, they cancel out. And that's the idea behind neutral fields. Again, we think about these as opposites. We'll just break these numbers down. Like here, I have a positive 4, and here a negative 5. That's like 5 negatives, or, we can think of it this way, as a negative 4 and another negative, right? And so what happens is if we kind of just visualize and say, okay, well, I know 4 positives and 4 negatives go away. They cancel each other out because they're opposites. That's the idea behind a neutral field, okay? Those two are neutralizing each other, and now I'm just left with the negative 1. And we don't want to write that out. We kind of want to do that in our heads. We want to use our imagination here. So like this one, I have 3 negatives, and then I have 5 positives. So think about it. Right here, this guy, 5 positives. I need 3 positives to cancel out that negative 3, right? Well, how many positives are left from that 5? Well, 2. So the answer here is 2. Okay, that's the idea behind neutral fields. And thinking about it in terms of a number line is a great way to do it. This is also a great way to do it. You have to decide what you like best, okay? Same thing here, the 3 and the negative 3. Well, those are already opposites. They just cancel out. It's a 0. Negative 3 and negative 5. Well, nothing cancels out, right? When you think about it, only negatives and positives cancel out. Since nothing cancels out here, I just keep all of them. If I had 3 negatives and now I have 5 more negatives, I have 8 negatives. I just got a bunch of negatives lying around, okay? This guy, same kind of thing. Again, change it. And here's where students get confused about neutral fields. We can't do neutral fields. We always want to think about neutral fields from the perspective of adding. So if I have subtraction, I have to change that to the opposite. So instead of 4 minus 5, I'm going to do 4 plus a negative 5. I'm going to change it to adding the opposite. Instead of subtracting that regular old 5, I'm going to change it to adding a negative 5. Okay? I'm going to do the opposite. And now I can think about it from that perspective of neutral fields. Here, if I take 4 of the positives and 4 of the negatives and cancel them out, I'm left with 1 of the negatives. If I look at this guy, again, change it to addition first. Instead of subtracting a negative 5, I can change that to adding a positive 5. I change it to the opposite, okay? And now, once again, if I have 4 negatives and 5 positives, right? Take 4 of the positives to cancel out that negative, I'm left with 1 positive, okay? This one, same kind of thing. Subtracting a negative, change it to adding the opposite. Instead of subtracting a negative 2, I'm going to add a positive 2, okay? It's the opposite. And 6 plus 2, well, nothing cancels out, so I just group them all together. There's 8 of them now, 8 positives. This one, same kind of thing. Change it to adding the opposite. Ready? Plus a positive 8 now. All right? And now from here, think about it. If those 3 negatives canceled with 3 of the positives, how many positives do I have left? Well, 5. Okay, 3 of them canceled out. I got 5 left of those 8. Okay? That's the idea behind neutral fields. It's a great mental math strategy for adding and subtracting positive, negative numbers. You just have to change it to adding the opposite first. You have to look at it from the perspective of addition, okay? And now let's talk about multiplying, dividing. Multiplying, dividing is no different than multiplying and dividing has always been. We just have to remember that that minus sign is an opposite sign, okay? And the opposite of an opposite is a positive. And we saw that when we were talking about addition. It's the same thing that happened up here, right here. Minus a negative 8 is plus a positive 8, okay? We're changing it to the opposite. And so if I looked at something like this, it's 4 times a negative 5 is usually how we refer to it. Well, just do 4 times 5. 4 times 5 is a 20. And then we have the opposite of that because there's an opposite sign here. So I tack on that opposite sign. So really, 4 times 5 is a 20. 4 times the opposite of 5 is the opposite of 20, which is a negative 20. Okay? This one, same kind of thing. I have 3 times 6 is an 18. But it says the opposite of 3 times 6. So I'm going to get the opposite of 18, which is a negative 18. Okay? This one, same kind of thing. 7 times 4 is a 28. And there are no opposite signs, so it just stays the way it is. And then this one, 8 times 2 is a 16. But now I have the opposite of the opposite, or you can think of it as the opposite of this negative, right? What is the opposite of a negative? Well, that's a positive, Mr. Jansen. Okay? And again, it's the same thing that we did right up here. In this problem, instead of minus a negative 8, I did plus a positive 8. Instead of a minus 8 and a negative 2, I did a positive, okay? And so the opposite of the opposite is a positive. This one, same kind of thing. 40 divided by 5 is an 8, but there's an opposite symbol there, so I'm going to do the opposite of that, which is a negative 8. Here, negative 36 divided by negative 4, well, 36 divided by 4 is a 9. And notice, once again, like we could tack it on and say, okay, there's 2 opposite signs. Okay, well, what is the opposite of an opposite? All right, what is the opposite of a negative? Well, that's a 9. Okay, and so the shortcut that hopefully you're seeing is that when the signs are different, like 4 and negative 5, I keep the negative. When the signs are different, like negative 3 and 6, I keep the negative. When the signs are the same, like 7 and 4, I keep the positive. When the signs are the same, like negative 8, negative 2, I get a positive answer. Okay, so when the signs are different, the answer keeps that negative. When the signs are the same, the answer is positive. Okay, but again, it's because we're doing the opposite twice. The opposite of a number is negative, and then when I do the opposite again, makes it positive. If I look at this one, 30 divided by 6 is a 5, but there was an opposite symbol, so I want the opposite of 5, which is a negative 5. Okay, that's the idea behind adding, subtracting, multiplying, and dividing, okay? Adding and subtracting, we either think about it on the number line, positives move us left and negatives moves us right. If we have 2 negatives in a row, we want to do the opposite. Remember, that's what a negative sign is. That's what a minus sign really is, okay? Or we can do neutral fields where we say, okay, positives and negatives cancels. How many positives do I have? How many negatives do I have? What cancels out and what am I left with, okay? And then multiplying and dividing, when we multiply 2 things with the same sign, the answer is going to be positive. Okay? When the signs are different, the answer is negative.